Hello, greetings everyone. Thank you for joining us today in our SmartNodes webinar. I am Robert, CEO of CleverThis, and sitting next to me today here we have Oliver, our head of technology.
Hi.
And we are going to be talking about SmartNodes, a tool that we developed at CleverThis. I will be giving a brief introduction on the history of CleverThis and connecting it to why SmartNodes++. And following that, Oliver will be doing a live demo. So he will be really creating a small application on the fly. How are you feeling about that today, Oliver?
Yeah, looking forward to it.
Looking
it's gonna
forward.
Be fun, yeah.
Yeah, indeed, it's difficult to see Oliver under pressure. So I'm going to invite all of you to use the comment section on the right of your screen. You can send your questions during the demonstration, during the presentation as well. And we will try together to put Oliver under a little bit of pressure. So maybe you can suggest to make some change. Maybe you can suggest to try something different. Let's try it out. So let me just start with a quick introduction to SmartNodes, in fact. So some of you probably already heard about this tool. I'm going to be telling you what are the values of SmartNodes to start with. So how can SmartNodes help you in practice? So one of the main features and one of the main reasons to use SmartNodes is like it helps you to structure your WinCC OA applications of projects in a way that you can multiply your engineering productivity. Your teams become more productive, and therefore your company becomes more competitive. Second reason, and also very connected to the first one, structured projects, you can significantly reduce your maintenance efforts and your cost, so you can focus in the following projects, and you don't have to have a strong focus on the ones that you have already commissioned. Maintenance becomes easier, so you're again saving costs. Third one, and very important, and very connected to the reason why we actually created SmartNodes, will be that you can actually quickly develop high impact operation management applications. So not only you're just connecting to the hardware and showing your customer a display, showing the valves position or showing the electrical breakers and so on, but you're actually able to start creating that sort of business logic, control logic that is having a very high value to your customer. SmartNodes can definitely help you to do this in a very quickly fashion, in a very structured and very maintainable way. And finally, you can also create, due to its portability, you can also create and perhaps even commercialize your own WinCC OA-based products, or even just move them from project to project across your different customers. So many of you already know CleverThis. I won't jump into this, just to connect it to the history of why SmartNodes. We are the core team of CleverThis is very rooted in scientific backgrounds, coming from high energy physics, coming from the CERN. But together with that, over the last years, we have integrated in the team a lot of talent coming from different places, coming from McKinsey, coming from GE, coming from Siemens as well. So we have a combination of R&D with industrial background, and our team has a successful track record providing consulting and software solutions for Industry 4.0 in many different domains, as many of you know, infrastructure, manufacturing, energy, and so on. Just to put in context, SmartNodes++ again, our experience back when we were working at CERN, Oliver here as well, it was working with these sort of ranges of size of systems. So we talk about systems with many millions of data point acquisition channels. We talk about systems that they are having some sophisticated needs in terms of features, no, in terms of business and control logic. And that made us understand the need of creating a framework or creating tools that could actually increase our productivity when creating applications and actually maintaining them for a long time. So when we left CERN about 5 or 6 years ago, we very quickly started working in industry. We realized the need of this sort of application or framework to allow us to become faster. And quickly enough, we realized that that was useful for other partners and even for Siemens, as we are about to show you first. So very quickly, we talk about multiplying your productivity to become highly competitive. So I'm just going to drive you through a story of how a project can be created through SmartNodes. And then Oliver will be doing this live for you. Let's imagine, since Oliver, I believe he will be creating a project which is very connected to maybe
manufacturing with the conveyor belt system, yes.
Some sort of conveying system and so on. So I'm going to show a little bit different, maybe more connected to pipes and valves and so on. So how would we start classically a project and also today with the SmartNodes++? We will start modeling the OT equipment, the operations equipment. We want to model our hardware, our valves and pumps and so on. So SmartNodes++ allow us to model in a way that we can continuously see what we are actually programming in WinCC OA. So we are creating different object classes, device classes like a valve, and we can see it continuously. We can see the attributes, but we can also see the methods, the behavior of these objects. No, so we will start creating valves, and of course, not only valves, no, but we also need pumps. No, we cannot do anything only with valves. And as soon as we start doing our OT, we all know in the different projects when they become a bit big, we don't have only one type of valve or one type of pump. We have multiple, no? And there we get into one of the main things of SmartNodes++, which is inheritance. So we are able to create derived classes. So we can have different types of classes, and this will look a little bit like this. I don't want you, of course, to read through this, but we can see that we have a valve, and we have a valve with regulation. And we also have analogic valves, and we also have valves with digital valves, flow control, even manual valves that they can have, again, some sensors to detect if they are open and closed. And then we can have as well, just to show one step forward, the connection to the real hardware. We can have all the different bits that they are connected to the position of the valve, the interlocks, the different things. So this will be just expanding a valve. And this will be actually, as Oliver will show later, very structured in SmartNodes++, and creating for you the data point structure in WinCC OA. But if we take a step back, we were talking about the valve, but there are things that they are using that valve in our system. So we can imagine a system where these valves and pumps, they are going to be used for some business or control logic. Just before that, we are speaking about modeling OT. What about modeling IT entities? What do we call here IT entities? They could be, for example, some external database, no? We want to model the connection to that database. We want to model the entities in that database. It could be an external system. It could be some protocol. It could be web services, just modeling IT things, no? Next thing that we will want to do with the SmartNodes is to model enterprise entities. What do we mean here with enterprise entities? We are talking about things like, for example, a work order. A work order can have a start time, it can have an end time, it can have a status. It's something that exists in the ERP of the company, for example. So it's an enterprise entity. And then following that, of course, the natural step will be, now I want to connect my IT entities with these enterprise entities, right? So I can connect work orders with my databases and so on. So I can download from the corporate database the work orders, which I have already modeled in WinCC OA through SmartNodes++. All the data point structure is configured there. So next step will be, I have connected my IT and enterprise entities. I want now to what we call bridging the IT-OT gap and develop operation management applications, let's call it like that, where I want to connect all of it. So I want to connect my work orders, which I'm downloading from a database, and I want to operate into those valves and pipes, which they are part of a network node, which is part of a pipeline, for example, and that pipeline is used for certain work order. So you see that everything starts to get connected, and we can even go one step further, where we have a work order. We have as well an order controller, which is in charge of executing that order. We have an order planner to plan that order in advance, to select which valves and pipes are going to be used, for example, for that order, to select the time, the schedule. So here we are connecting with the SmartNodes++. We are really bridging inside WinCC OA the IT and OT walls, both of the realms, like we can see with these two arrows. No, so and there are two different walls that they have different life cycles, right? IT perhaps has a different speed. Programmers, developers changing business logic or control logic. OT more engineering, connecting to hardware, different types of valves, different types of pumps, and so on, and with different cycles. And SmartNodes++ allowed this for this parallel work, in fact. Just to finish before we put Oliver under pressure, a few references just to share with you who is already using SmartNodes++. Digital Station Manager, you probably heard about this, is using a SmartNodes approach. Impact benefits, moving from projects to actually have a product which is configurable. So we are not developing in WinCC OA to make a new system. We're actually configuring a product to deliver a new metro line or a new station, a new control system for this purpose. Accelerated development through simple configuration, easier maintenance, and of course, faster support. We have also in the petrochemical and oil and gas storage systems, full project developed using SmartNodes from top to bottom, the complete digital twin and modeling of the plant, all of the assets, which are afterwards, of course, tracked, integration of multiple third-party systems, access control, barrier control, traffic control, and so on. Also digitalize all of the work orders, the execution, and the reporting using the SmartNodes. And it has features, for example, like chemical calculators to actually create certified quantities and so on. All of it modeled in SmartNodes++ and connected in the same way I showed before. In the manufacturing as well, here we have a machine maker in the food and beverage, develop a full POC, proof of concept. Idea here is that they can create new machines without having in practice WinCC OA knowledge. So just using the SmartNodes++ configurators, they're able to define new machines and define how these machines are connected to the 3D models, where they can see how the alarms are connected to the different parts, how they address the hardware as well. So they connect really the logic with the visualization, and everything is interconnected through SmartNodes++. Great customer engagement indeed. In the energy sector, wind power, training plus proof of concept. This is in Taiwan, Rallytech and Copenhagen offshore partners. Wind park proof of concept developed in 3 weeks by CleverThis using SmartNodes++. Project finally awarded to our partner Rallytech, which is now developing the full project. And finally, but not less important, in fact, because we are very actively working now with Siemens Intelligent Traffic Traffic Systems, Siemens ITS. We are supplying SmartNodes++ and providing consulting, and they are using SmartNodes++ to build the new products for highway and tunnel control systems. This is reasons behind this: boosting productivity, increasing the quality of the projects with automated builds and test environments and so on, enabling, very important, we talk about portability of SmartNodes++, so enabling parallel development of features across the different teams in the application. And actually, I believe that the version of SmartNodes++ that Oliver is about to show is pretty much coming from the oven. We've been working with Siemens ITS in improving some of the features that they were very interesting for them in the last weeks. So I think it's time to put Oliver under pressure. So I'm going to switch to moderator mode. Oliver is going to go into demo mode, and please send the questions in the private chat. I will receive them and I will be forward them to Oliver.
Thanks for the introduction, Bobby. If we just switch over to my screen, then I will show you how we're going to use this to build a project. So we have half an hour left, so that should be fine for time. What I have here is I have a WinCC OA 317 project with SmartNodes++ already installed. It's easily installed as a sub-project, so it's very quick to do. And I have this manager in my console, which is the SmartNodes IDE. And if I start this up, this is the development environment of SmartNodes. Along the bottom, you see that we have these 6 main tools: quicker, checker, molder, mutcher, ladder, and builder. Now, these are all required for individual steps of creating a project. So doing some of the IT parts, the development parts, or doing some of the engineering parts, or finalizing and packaging the application and installing the application. So we'll be stepping through all of these, not in all the details, but enough to see the flow and how they're used and the kind of person who might be most specialized to use the different ones. So the first tool that we start with is Quicker, which is where we create our classes that represent the equipment, the objects that we have in our systems, and where we can start adding code which represents the business logic as well of our system. So as I said earlier, we're going to be creating some sort of conveyor system. So I'm going to create a class called a conveyor, and this one I want to store in a directory that I've got called assets. So these are finally going to be created as control scripts. It uses WinCC OA functionality behind the scenes, so it's all using the native functionality that's already provided by WinCC OA. We create that, and we have our new class here, and I can open here, and we see our script editor. So let's start adding some properties. This is going to have a Boolean that represents the running state of this conveyor. We're also going to have a string, which is going to represent the product ID on the, just wait 1 second, I think you're not seeing what I'm seeing. So
yeah, we're getting used.
Yeah.
Okay. So we were seeing Oliver face, but now maybe you need to go back to and now speed up a bit more.
Okay, that's fine.
So we're already putting you under pressure.
I go back to the beginning then, yeah.
Let's go back to the beginning. Yep, I think it should be okay. Send live.
Now it should be fine, yeah.
That was moderator's fault. Okay,
good. So now you should be able to see what I'm seeing on screen. I start again. We still have more than 25 minutes, so let's go. Let's go now. So what I'm doing here is I'm creating a new class, which is going to be called a conveyor. And this I'm going to create in my assets directory here. So now we've got my class, and I can immediately click here and start seeing the code inside the class. So SmartNodes has created the template of my class, and now I can start adding the attributes. So the one that I was talking about before was a Boolean that represents the running state of the conveyor. And the second one that I was just doing when we realized there was the technical issue was a string representing the product ID. So this is going to be a product which is passing along the conveyor at that moment. So I've created these as private attributes of the class. To access them, we need the getters and setters. So in SmartNodes, we follow the getter and setter pattern. If I do that, you'll see that we get this wizard that helps us create the getters and setters for us. So there's a lot of code generation going on here. So it's very quick to build up your classes. You don't need to worry too much about the details of the syntax there. And okay, we already have a conveyor. If we click back here, we see that now this view is updated, and it shows that we have a conveyor with those two attributes and those getters and setters that we created earlier. The interesting thing is that this is actually already creating things in the para module as well. So my class has already been created as a data point type in para. And if I come here and create my first conveyor, and then, for example, we can see a UML representation of our class that we've created here on the right. That takes a few seconds to generate. So we see that ours is a conveyor class inheriting from a smart object. All of the classes by default inherit from smart object. We also have checkit, which is a place where we can see a small visualization. So I've already created a visualization for this conveyor. And if we try and update an attribute, we should see that it should update, but I'm seeing that it's not. This is due to the fact that these are actually creating WinCC OA libraries behind the scenes. So if I restart that, then it will quickly come back and we can try and simulate that device again. Okay. We come back to the conveyor. Let's open the UML and check it. If we click there, we see the visualization now. And now if I try and set the attribute again. Okay, now we see it goes to true, and we see that the visualization is working as well, and it's going to a green color. If we set it back to false, it goes to the gray, blue, neutral color as well. And to double check in PADA what's going on there, you see that this is created as a data point, and it has that running value there, just like we see here as well. And the product ID is empty. The other attributes that you see here are internals, which are required for the functioning of SmartNodes++. Okay, so that's how to create a simple class. We can look at the next module now, which is called Checker, and this is for unit testing. So I'm not going to spend too much time here, but I will just show you the principle. We can create a test class to test our conveyor class. If I look at the code in here, you see that I've already got some skeleton code already prepared to run these tests. And I can generate tests for specific methods that exist in the conveyor class. So here, for example, these are the methods that we have in the conveyor class. There's nothing very complex at the moment, but let's say we want to test the set running. We have to define the conditions that we want to run and the expected results. So let's say we want to start it, and then the expected thing is that it is running. Okay. Now, in this test, we already have a test object that's been created for us in the skeleton. So we can say test object dot set running, and we set it to running true. Then what we're going to do is we're going to get the running state equals the test object dot is running. And then we want to do an assert. We don't want to assert fail because that will fail all the time. What we want to do is assert true to check that that running state is actually true. And we can say that the conveyor should be running, which is the expected thing. And if not, we'll get that message saying that we were expecting that the conveyor should have been running. Okay. We could run that test. These tests are run in control managers, so they don't interfere with our systems as such. You can run them standalone, so they have a clean environment to run in. That's marked in a green color. It ran in 0 milliseconds, so it was very fast. It was a very simple test. And the green color indicates that it worked. The code coverage is 60%. So we executed 60% of the lines in the conveyor class. The class is very simple at the moment, so it's quite easy to achieve that. Just to think.
I have a question here.
Yeah, sure.
Since you're catching up in time. When would you use unit testing? What is it useful for? Or when do your teams find it useful in the past, unit testing? What is this scenario that you're building some logic and then you want to, what is the purpose?
So there can be many situations where unit testing can be very helpful. If you're in a project with a very long duration where people will be maintaining the system, in maybe many people who weren't the original developers as well, they may change some pieces in the code. And they want the assurance that they're not breaking other functionality when they do those changes. You may also be working in projects where they're doing very high safety standards, and that may be part of the requirements for certification or something for the project that people are doing. Okay, the point that I wanted to raise here is that we know that these are tests to be run because we have annotations. So annotations are supported, they're added by SmartNodes++ to the Control++ language of WinCC OA. So that's how we know that that is a test case, using that annotation there. Okay, not to spend too much time there. Let's now jump to Molder. Now, Molder is the preparation phase for the mass production, mass generation of objects. So this is still a bit the specialist role who's developed this object. They define the template saying, okay, when you create these objects, which parts are going to be, what things need to be configured on these objects, whether you need addresses, archiving, alerts, and so on. So let's think about the case here. For the conveyor, we had the running signal. Now the running signal, we imagine that we can read it from the hardware. Let's see, we have these different types of addresses here. So we could have done Opc Ua, and we create what's called a splice, which is a definition of what's going to be configured on the running attribute in terms of OPC addressing. Just need to update here a bit. Okay. Okay, then over here, when we look on the splice, we can see the attributes that are going to be specifically set related to the addressing. So if I look here, these are particular properties related to Opc Ua addressing. May be familiar to you or maybe not, but I will just go through and pick some default values here. This would be the OPC item dot, for example, is on. It could be. The data type is Boolean here. We don't need polling because we're going to be subscribing to this data live. We can have some low-level smoothing. We can enable the history mode of Opc Ua. I'm just going to use driver number 1 to start with. And the direction I'm going to say is in and out, and it's going to be spontaneous because we're subscribing to this. Now, this is fine. This will work. This is a valid configuration, but the OPC item name in the server is not always going to be the same. If we create multiple conveyors, we're going to want to read slightly different items from the OPC server based on the naming convention that the OPC server is using. So to do that, we can use these parameters. So if I put a parameter saying OPC Ua conveyor name. So this is the conveyor name as represented in the namespace of the Opc Ua server. If we edit back in here, and I'm going to add that as a parameter here. Now let me just switch that around and put it to the beginning. That means that this part of the string between the curly braces can be substituted later on per device instance. So it's no longer a static text, it's actually going to be a dynamic text which can be defined for each conveyor that we create. Okay. So now we have to actually create a mold. So this is going to be a conveyor mold. And we can put one or many splices into that mold over here. So now that mold is configured. We have conveyor mold containing this one splice that's going to set up an Opc Ua address on the running attribute. So now we switch to the next tool, which is called Mucha. And Mucha is really about project engineering, about mass production of the items that you need. So depending on which site you want to deploy an application, you're going to have different conveyors with different addresses in the OPC server, different names. So if we click that mold, you see that there are other molds already existing from SmartNodes++, which you can use by default. But the conveyor mold is the one that we've just created. And we can create a new file here, which is going to be the conveyor definitions. So this is the definition of the conveyors that we're going to create in our system. We can double click this and this will open in Excel that I have locally, but it's a CSV file, so any CSV editor is fine. And we have two columns. The first one is the name of the conveyor object. So I'm going to create conveyor 1. And to do some mass production, I'm going to do 15 of those. And the Opc Ua conveyor name. So the name that this is represented in the OPC server. So this could be server.conveyor1. And again, we can just fill that out there. I'm going to save that. We close that. And now if I drag it into the editing area here in the center of the screen, it shows me a preview. These are the objects it's going to create. They're yellow at the moment because they don't exist. And we can see the details of the addressing it's going to create. So I create there. And just to check in the para, just to show that there's something happening behind the scenes, we can see that we have the conveyors with the running and the addresses already defined.
Yes, Oliver, I have a question here.
Yes.
WinCC OA has already some powerful mass configuration tools through the ASCII manager. So what are the pros of using this approach? Can they be combined? What do we have additionally using SmartNodes++ for mass engineering, let's say?
Sure. So, I mean, the ASCII format is a valid method, and certainly nothing that happens in SmartNodes++ prevents you from using other parts of WinCC OA. There's no way, it's not preventing you from using the other tools that you may be used to. But the big advantage here is that your engineering files are CSV files. So you can see them very easily, you can edit them very easily. There's no special syntax of spaces and characters that you need to follow to get an exact match that the ASCII manager will be able to interpret. And also the parameter mechanism is very powerful. Having those parameters that you can define any number of parameters for a mold.
Could we, what if my OPC tags, for example, they will be made of 2 parts of a string that I want to concatenate?
Sure.
Can we do that?
Yes, we can do that.
Yeah.
So we come back to the definition of the mold in Molder. We look here, so we're going to need a second parameter. So this is going to be Opc Ua tag part 2. We could then edit here, and for example, we could then put that straight on the end here. Opc part tag 2. We come back to Matcha, and as soon as we look at this file, it's going to say, there's something missing because you've now specified 2 parameters and there was only one defined before. So now you see that this second column has been added for the second parameter, but it's still empty. So we could fill that in here, just expand those column names so you see it more clearly. And this would be the suffix.
It could be a suffix for half of the first ones and a different one for the second one.
Okay, yeah. So that would be, let's just keep it as A here for the first.
People might be thinking that this was prepared already.
And then here, let's go for
B. At B.
Okay. Now let's refresh that.
Why did it go? Why did it go orange before? It was orange, right? And now it's green. And what is the meaning? And what is the benefit?
The green represents whether the object exists or not. So here it's saying that it exists, but there is a difference in the configuration here that will be applied. So it's not going to be exactly the same configuration, but it shows that the object already exists. So you know that you're going to be able to, you know that you're going to be overriding or reconfiguring an existing object. So it's an indication that it's already there and you should take care. Okay. Yeah, this is locked by the PADA module, in fact. So I was showing you in the PADA module locks the configs when it's open. So now if I try it again, with the PADA module closed, it should have worked this time. And if we look back here, you see now this is conveyor 1, it has the A at the end. If we look at one of the ones with the higher numbers, we will see that the running has the B at the end.
Okay, that's great. So what you're saying is that before importing actually the file, you have a chance to look and see what are the changes that this file is going to bring into your running system.
What you can do is you can click here, and for every single splice, you will see a list down the right-hand side. And here we have 1 splice in our mold, and we see the visualization of what's going to be applied. So yes, we can see that this will be applied in our system when we click the Generate Objects button. Yes.
We have another question, Oliver. They're asking if it is possible to change individual attributes after generation. I assume the question is if it's possible to change address attributes or whatever attributes using.
Yes, I mean, in principle,
Like
you can go back and jump back to any of these steps at any moment that you like. So if we come back to quicker, we could add an attribute or change an attribute name.
We should, since someone is asking, we should probably.
Let's add one here. Yeah, let's make a new private. This is going to be integer, which is going to be the speed, let's say. Now let's generate the getter and setter for the speed. That's there now, and I click OK. And if we look back in the pattern now, you see that the speed is already there, so it's fine. You can add and change your classes as you go ahead. Of course, if you're removing attributes, you need to be aware that you're removing the data and all the configuration associated with that attribute. So you have to take care with removing. Adding is very safe, so certainly you can do both, but you need to take care with the removal part of it. Yeah. I hope that answers the question. If not, let us know.
Please let us know.
And we'll take a look at that. Okay. The next tool, so now we've got our big bunch of conveyors created. We've got 15 created. Now we have a way of controlling what in WinCC OA terminology is called the plant model or the CNS views. And in WinCC OA terminology, we call it the ladder because it's about building hierarchies of objects. So here I've already got some data predefined just to make it simple for the demo here.
Oh, you're not doing it live.
So here we have hierarchy. You see that my project is actually a dual language project, so I have French and English strings. If you have any other language project, it will work with your project as well, and you can define the languages of every language specific string in the Excel file as well.
Who created the template of this file and the headers, Oliver?
So the template files are always created by SmartNodes++. So like you saw, if we go back to Mucha, if I come here to the conveyor mold and I create the file, another file, is that the headings are already filled in. So SmartNodes++ is taking care of creating the formatted file that you need with the correct columns that you need. Okay, the one with the hierarchy is basically a hierarchy representation in a file. So the first node is called factory A. Then line 1 is going to be a child of factory A. That's the way it works. We look at this parent column here. And then these line 1, conveyor 1, 2, 3 are children of line 1. And the same here, line 2 is a child of factory A. And conveyors 1, 2, 3, 4 in line 2 are, and you see there's a typo there, there should be 2. And that should be 2. These children of line 2 are, we see they're children of factory A dot line 2. So it means that they're direct children of line 2.
So you're creating like a hierarchy?
I'm creating a hierarchy of those objects, yes. And the advantage of these hierarchies is that you can use them in many ways. You can use them to group devices together or navigate through the devices. And in fact, in one example here that I have a panel. This is a panel that I wrote earlier, but it uses the data from that view to create the lines that we've defined. So it visualizes line A1, line A2, and it shows the correct number of conveyors in the file. Okay, that's easy to do it once. Let's try it a different way with a different
layout, no?
Layout,
that
exactly.
One you prepare in advance.
That one could have been there already hard-coded in the file. So let's create line 3. This is a child of factory A. And let's call this line 3 C1 A31. We still have conveyor 8 free, and this is going to be factory A dot line 3. Okay, let's refresh that. We see again here that the white ones are not existing.
So even before you create them, you can already see that they are in the file, but they are not in your system.
You
so
see the difference. Yes, it's doing a comparison. Yeah. Now I generate, and that should exist now. And if we generate, run the panel again, the panel explores the CNS hierarchy and creates the correct number of lines with the correct number of conveyors that need to be visualized. And these can be controlled just like we saw before. There's also the 3D view, which is actually another product from Cleverdist, which is called Zoom in 3D. And this is also, yeah, this can also be animated and show various error states and help people investigate and explore the problems that they may have in their system. Okay.
Do we want to add more conveyors, or we don't have many free?
Do we have time?
You have 3 minutes, Oliver.
Okay.
Can you create 100 conveyors?
No, but we.
No? Okay, you have something.
I'm going to create a. So we had the concept of the product ID, and so far we haven't created any products. So let's create a product class here. This one, let me just put it again in the assets directory here. Let's create that as an asset, and let's create some property of this product. So what's it going to have? I'm going to propose that one interesting parameter of a product is the weight of the product. Let's generate the getters and setters for the weight. Now we have the weight there. And if we come back to the panel that we had earlier, okay, now the panel has detected that there are products available and that we could place a product on the conveyor belt. And actually I have a simulator, which will make things a bit more lively. This simulator is written in SmartNodes++, and now you see if the conveyor is running, the products actually travel along from one conveyor to the next. And if they get to a stop conveyor, they stop here. And those products can be placed on the conveyor. Now, product is a bit general, so we could create different types of product. We could have, for example, a suitcase.
Suitcase. Yeah.
If we imagine that this was a baggage kind of conveyor.
Like at an airport, for example.
Yes, for example, yeah. And yeah, that's okay here for the moment. If we come back here, we should be able to place a product. You see it's detected that there are different product types available. And I could say put a suitcase there. Okay, you even see the icon is there. Now, you may be thinking this is a bit magic. This is a bit strange that it's already there. Actually, I prepared the panel in a way that it bases the search for the picture on the class name. So this is my project directory. If we look in the pictures, I have a picture called a suitcase, and I have a picture called a tire. So that could be another product type. So let's go and make that now. Let's create a new product type tire. And if we come back to our panel, we should also be able to start putting tires down the conveyor belts.
Great.
Okay.
That's fantastic.
I just finished off with the final module then of SmartNodes++, the builder. Builder is a way to wrap up all the work that we've done so far. So we know that to create this project that we have now, I have my engineering file, which is the conveyor mold with the conveyor definitions, and I have my ladder file with the shop floor and this simple configuration over here. Builder lets me create a recipe to create the whole factory recipe. So I can say, okay, what should this recipe do? And it's an ordered list. So the first thing I want to create is a conveyor mold, and I want to import the file, which is the conveyor definitions. And then I want to import the shop floor ladder, and I want to use that simple shop floor plan that I had. And that's going to apply these in order. I can run it here, and it will create all of those things as a kind of deployment method.
It's like an installation tool somehow.
Exactly.
Right?
You can install your full project if you have molds and ladders for all of the things that you need to create. You can build this recipe, this sequence. You run the sequence. You can also run it from a script. It's not just from the graphics here. And that will create all the necessary instances that you need in your project.
Let me profit that we are talking about these files to throw at you one question that we are getting from our attendees, which is it possible the generation tool has some sort of version control? Because apparently this person claims that one of the main problems with PARA is the lack of version control of your project and so on.
Yes. That's very.
How do we manage that?
It's very true. The way that we do with SmartNodes++ is that we make sure that all of the things that we create in SmartNodes++ exist outside of PARA, let's say outside of the internal database of WinCC OA. So what does that mean? So first of all, I mean, if we look in the Getty, you see that all of the files that we've been working on are actually standalone project files. Even the classes themselves, if I wanted to pass my conveyor class to a colleague, all I need to do is I need to pass them this file. I don't need to do an export of the database. I don't need to do a DP export of the type. I just pass them this file. They copy it into their SmartNodes project, and they can register it, and they get immediately the new class. And I'm going to show how we do that. So this could be colleague conveyor. So this is a conveyor that came from a colleague here. That should be fine then. And I need to rename the file as well. Colleagues conveyor. Okay, so this is a class that I don't have in my system at all yet. If I come to Quicker and I check a registry of all the classes, it will search through my project. And here, okay, there's one unregistered class. The missing class at the top is because I actually renamed the conveyor, so now it's missing. But this one is the colleagues conveyor, which is unregistered. If I click that, then it will register it. And we see it's back in there. It's got the same attributes and methods as we were expecting from the conveyor. And if we look in PARA, it's already there. And the same applies for the molds and the engineering files of Mucher and Ladder. It's all of that data can be exported.
The question was probably also very related to the version of the configuration, no, of the devices. So.
Yeah, so the version of a configuration would basically be a version of all of those typically CSV or control script files which are exported from SmartNodes. So all of those files live independently of the PADA, the RIMA database inside WinCC OA. So for example, if we look in data, we can see all of those ladder files, we can see the mold files, we can see also the sequence files. So all of those files can be put into a version control system, versioned there, and then pulled out and deployed. You can even do automatic deployment, like we showed with the builder module. If you copy all of your files across into a new project, register those classes, and then run the build procedure, you will create the full project from a version set of files that you could have got from a version control system.
I see we are going a bit over time, but I see that there are still questions coming.
Okay, sure.
So I'm going to keep asking that. Yes. There is one that is related to when we were creating with Molder, we were defining the different attributes and how to match them to that Excel file. Mm-hmm. How would you manage if you have many devices which follow one pattern, but suddenly you have another device that follows a completely different pattern? Okay. Perhaps it was not clear. You can use different files. You can.
Yeah, exactly. Yeah, that's okay. Now I've got my conveyor. Okay. So yes. So the question is how can you handle different conveyors of different types? So let me fix my conveyor first.
Perhaps only the conveyors are not different type, but you need to configure them in a different way, which is the case, by the way, that we've seen in industry many times. No, we have many lines, for example, and some of them were developed by a system integrator, some others by other ones, and the PLCs are programmed differently, and we need to address the hardware in a different way, though the conveyor is the same one.
Okay, so what I'm going to do is I'm going to set up, this is the OPC item, whichever we had before, is on. So we assume that we have one reading with Opc Ua, and like Bobby was saying, there may be an equipment with the same equipment, but that's read out, for example, in a different technology. So, okay, now we have our Opc Ua, so this could be Opc Ua Conveyors. Okay, but we may also have some which we read out in a different technology. For example, let's say we read out them with S7. So we can create another splice for S7. Here, let me have a look here. I would need to create some PLC internally in my project. S7 PLC. Okay, and I'd better get a poll group while I'm at it because we will need a poll group. PLC polling. Okay, so we come back here. What's the device? It's going to be that S7 PLC I created. This would be db100.dbd50, for example, just choosing something. This is the polling group I created as well. The type is a bit. We're still on a Boolean value. Low level could be true. Driver could be probably different. This time it should be 2. And this would be in and out polling. Okay, so then we can create another mold, which is called the S7 Conveyors. We click here and we put the S7 splice into it. So then when we come to Matcha, we can choose whether we want to create Opc Ua conveyors or S7 conveyors. They will create them of the same object type, but they will be configured with different addresses based on what we need.
I understand that you could have S7-1 conveyors, S7-2 conveyors.
Yes.
Because even if they are S7, they are still different.
Exactly. If you're reading them from different PLCs that were made by different teams, and the way the data addressing is done is different, you can manage that. Yes, certainly.
Very often. Okay. One more for you, Oliver. Question is, can you encrypt your project? So the work that you generate with the SmartNodes, do we support that?
So it's something that we have in the pipeline, and we've done it in other projects. Though it's not part of SmartNodes++ itself yet, but it's something that we have in mind, certainly.
Okay. Another one is, how does this work with distributed systems? Yeah, this is one part. How does it work with distributed systems? First one, maybe. Yeah. Okay,
so the first point, more or less, is that what we're doing here is we're engineering in one system. If we want to have the same classes across multiple systems, the moment it means copying those files and registering them on every part of the distributed system. So that's one question about, let's say, handling the development process and synchronizing the development across the projects, which is basically just synchronizing the scripts and then registering the scripts on the multiple distributed projects. And then the second one, which maybe is part of the question as well, is when I'm creating a data point object here, so when I create a conveyor, this is a conveyor in my system, but I could also create it in a remote system as well. So I can have a data point on a remote system, which is running in an object that runs in my system as well. So if you want to be able to pull data across from other distributed systems, but still have that object-oriented SmartNodes++ interface, you can do that as well.
Okay, a good one coming here as well. Is this SmartNodes++ multi-WinCC OA version?
Okay, so the versions that we support at the moment are 3.16 and 3.17. That's, yeah, so we're keeping it like that at the moment. That's what's available as of today.
Okay, hold on, because we just getting many more. Let me read this one. It says, this one says, okay, thanks. Is able to support multi-language scenario? Is the question. Is it able to support multi-language scenarios?
Yes. So as I said, we have a project here. My project here is French and English.
Maybe you can add some string to the conveyor.
I will create
some attributes.
I will create an alert text, I think.
An alert text. Okay, we are going a bit over time.
So if we go on this,
in defense of Oliver, I would say that it was the fault of the moderator because we have some minutes. So please, Oli.
Okay, sure. So let's look at the, for example, we want to put an alert on the speed, let's say. So I'm going to create an analog alert on the speed. Let's have a look here. And okay, so what do we need for an analog alert? We need to choose the classes, the text, the limits, and whether it's active or not. These are DIN values because it's a multi-range alert. Actually, I might, just for time, I go back and do the running because it's a Boolean.
It's
one.
A Boolean already.
It will be quicker.
For time, yeah.
So we don't take too much time there. That's a digital alert. Digital alert. Digital alert on running. So digital alert on the running. It'll be a bit quicker this time. Okay, so what do we need to define here? We need to define the bad alert class. So let's say that's alert. The normal value is going to be 0, false. Then we need a text for OK, bad text, and we want it to be active. So yes, we definitely want the alarm handling to be active. What we want is we want these strings to be defined by the engineer, for example. So let's say this is going to be the bad text here, and I've chosen a parameter of type lang string. So that's going to be a multilingual string. So if we come to bad text here, we put the bad text parameter in there, and then we can have an OK text. The OK text we can put there. Okay. So now if we come to Matcha, I have to create this, add this to one of the existing things. That's saying the Opc Ua Conveyors. If we look in Opc Ua Conveyors now, I'm going to create a new file, Opc definitions. And if we look in this file, what we'll see is that we have a few more columns this time with the language strings for the running state or not. So let's create a conveyor. I don't know which number we have, 3, let's say 20. This is the bad text in English, bad, in French, mauvais, good, bon. Okay. Now, if we generate that object and we go to the Palo module,
let's check that out.
Conveyor, that's going to be the running and the alert handling. Oops. Alert handling. Now, okay, if I just delete that, you'll see that it got those language strings for English and French there. So the good, the bad text. So yes.
Fantastic.
Everywhere you need, you can do multi-language strings. Yeah.
I have a question coming up. Please keep asking. We know some of you will probably need to leave, but we are happy to keep answering some of your questions. I see there are some arriving. Next one, it says audit trail. Is it supported too? I think I can actually answer this one because we recently used this feature in one project. In fact, as Oliver, maybe you can show in your conveyors, for example, the setter of a conveyor. And we will see in the setter of the conveyor, setter will normally just set the value of a data point. So for example, set the conveyor to run will set the value to true. But as you can see, you can override the default automatic generated for you behavior, which is set the data point. And there you could actually call the audit trail function. So here you could go and say audit trail, get user, and set that this user send the command, this command to this conveyor. So the answer is yes, it's totally, and actually we've done, and it's very easy to integrate with WinCC OA audit trail. Or if you have different needs that they are not covered by that, the default native even extend the audit trail functionality like we have done. So yeah. think that audit trail, I'm looking there, Oliver, to see if there is no other questions. Otherwise, I think we actually cover everything we wanted to cover. That was great, Oliver. Let me just switch to presentation here and here. So yeah, thanks everyone. And actually, if there was if there were questions that were not answered, please send them to us, hotline@cleverdisk.com, and we will be really happy to answer your questions. Yes, just thank you. Yeah. Thank you, everyone. And again, hotline@cleverdisk.com. We'll be happy to answer your questions. And have a great day and stay safe.
Thanks for your time.
Thank you.
Bye-bye.